For the last century, humanity slept soundly, believing we knew exactly how our universe began and where it all started. We taught it in every school, printed it in every textbook, and called it the absolute truth of our creation. The Big Bang was the comfortable story that explained why we are here and exactly where we are going next. But recently, a machine we launched into the deep dark sent back a message that terrified astronomers across the globe. The numbers did not add up, and the images defied the laws of physics we held sacred for so long. You might think the ground beneath your feet is solid, but the history of reality is crumbling beneath us now. We looked back to the absolute dawn of time expecting to find chaos, but we found something physically impossible. Instead of a newborn universe, we saw monsters that were too big, too bright, and far too old to exist. It was like digging into the earth and finding the bones of a modern human buried in dinosaur rock. This discovery does not just rewrite a textbook, it threatens to shatter our entire model of modern cosmology forever. If the beginning of the story is a lie, then everything we predict about the end is also wrong. The James Webb Space Telescope was designed to see the first light, but instead, it saw ancient ghosts waiting. These galaxies existed hundreds of millions of years before they were physically allowed to form by the laws of physics. There is simply not enough time in the universe for these massive structures to have assembled themselves so quickly. Scientists are scrambling, desperate to fix the math, but the anomaly refuses to go away no matter what they do. The standard model of cosmology is currently bleeding out on the operating table of science, and we cannot save it. We are facing a crisis in physics that suggests the universe might be twice as old as we previously thought. Or worse, that our fundamental understanding of gravity and time is completely broken and needs to be rebuilt from scratch. Imagine waking up to realize that time itself has been playing a trick on your perception for your whole life. The light from these impossible galaxies traveled for billions of years just to break our hearts and our theories. We call them the universe breakers because they violate every rule of cosmic evolution that we have ever written down. Some astronomers are whispering in the dark that we might need to abandon the Big Bang theory entirely right now. This is not just a scientific debate. It is an existential emergency for the human race and our place here. If we do not know where we came from, we have no way of knowing where we are going next. The darkness of space is no longer just empty. It is filled with questions that have absolutely no answers. We are staring into the abyss, and for the first time in history, the abyss is confusing us completely. Every telescope we point at the sky reveals more cracks in the foundation of our reality and our understanding. The smooth expansion we predicted is actually jagged, chaotic, and potentially terrifying for the future of our existence. We thought we had the map of the universe, but we were looking at a child's drawing the whole time. The real universe is a place of violence and impossible anomalies that defy explanation and mock our human intelligence. Is it possible that the universe has no beginning and will have no end, trapping us in eternity? The concept of eternity is terrifying to the human mind, yet the data points to it with cold precision. What if the Big Bang was just a local event in a much larger, darker ocean of infinite space? We are drifting on a small raft of logic in a sea of chaos we cannot comprehend or control. The deeper we look, the more the universe seems to be mocking our attempts to understand its true nature. We have found galaxies that are red with age when they should be blue with youth and new starlight. This color shift is the bloody fingerprint at the scene of a cosmic crime that happened billions of years ago. It suggests that the universe was fully mature when we thought it was just being born in the darkness. This paradox is known as the crisis in cosmology, but that name is too polite for the horror it implies. It should be called the collapse of our arrogant assumption that we understood anything at all about the cosmos. The silence from the scientific community is not peace. It is the silence of shock and absolute terror. We are rewriting the scripts, recalibrating the sensors, and praying for a calculation error that will never come. But the data remains stubborn, staring back at us with cold, hard indifference to our human fears. We have opened a door that we cannot close, and we must face what is waiting on the other side. The comforting story of the Big Bang is dying, and a stranger, darker story is taking its place. This new reality is colder, older, and far more mysterious than we ever dared to imagine in our dreams. We are about to embark on an investigation into the greatest mystery of our time and our existence. We will examine the evidence, question the experts, and look the anomaly in the eye without blinking. Prepare yourself, because the universe you thought you lived in is gone forever, replaced by something much stranger. The investigation begins now, and the evidence suggests we are terribly, terribly wrong about everything we know. To understand the magnitude of this cosmic crime scene, we first have to look at the perfect alibi that physics has relied on for decades, the Standard Model of Cosmology, or what the general public simply calls the Big Bang. For nearly a century, this theory wasn't just a good idea. It was the only idea that fit the evidence found at the scene of the crime. It elegantly explained the cosmic microwave background radiation, that faint, static hiss of heat left over from the initial explosion, and it perfectly predicted the abundance of hydrogen and helium that makes up the vast majority of our observable reality. It was a beautiful, symmetrical mathematical structure that promised us a chaotic, hot beginning that cooled down over 13.8 billion years to form the structured, orderly galaxies we see today. But in science, elegance is often a mask for ignorance, and we are now realizing that this perfect alibi was hiding a terrifying secret about the true chaotic nature of deep time. The universe didn't just cool down and organize itself. It was seemingly born with scars and structures that should not have been possible in those early violent milliseconds of creation. The primary forensic tool we use to map the history of the universe is a phenomenon called redshift, which serves as the odometer for cosmic time. As the universe expands, the fabric of space stretches, and the light traveling through it gets stretched along with it, shifting its wavelength toward the red end of the spectrum. The rule was supposed to be simple, absolute, and unbreakable. The redder the light, the older the object, and the farther away it is in the timeline of existence. We built our entire understanding of cosmic history on this ruler, assuming that as we looked back to the highest redshifts, the dawn of time, we would find only small, messy, incoherent blobs of gas just starting to wake up. We expected to see the cosmic nursery, a place of chaotic infancy where gravity was just beginning its slow, clumsy work of pulling matter together. Instead, the data coming back from the edge of the observable universe is showing us something that defies the laws of stellar evolution. The light is red, yes, but the objects aren't the messy infants we predicted. They are fully formed monsters that seem to mock our linear understanding of time. Enter the detective that blew the case wide open, the James Webb Space Telescope, a machine built with the specific purpose of peering through the dusty veil of the early universe to confirm the Big Bang's timeline. We launched this $10 billion time machine with the arrogant assumption that it would simply validate what we already knew, providing higher resolution images of the standard model in action. But the universe does not care about our investments or our arrogance, and almost immediately, the telescope began beaming back evidence that turned it into a hostile witness against current physics. The telescope's infrared eyes pierced through the cosmic dust and revealed galaxies at redshifts that correspond to a time when the universe should have been less than 400 million years old, a blink of an eye in cosmic terms. By all established theories of gravity and matter accumulation, these epochs should be dark, filled only with the first tentative stars flickering in the void. Instead, JWST found bright, massive, unexpected structures that have no business existing so early in the timeline. The most damning piece of evidence is the discovery of galaxies like CEERS 93316 and others found at redshifts greater than 10, which theoretically places them in the universe's infancy. The problem isn't just that they are there. The problem is their impossible mass, which rivals that of our own Milky Way. To put this in a perspective that chills the blood of astronomers, finding these galaxies in the early universe is the cosmic equivalent of walking into a hospital nursery and finding a fully grown middle-aged man sitting in a crib. It violates the fundamental speed limit of gravity itself, because there simply wasn't enough time between the supposed bang and the formation of these galaxies for matter to clump together on such a massive scale. Gravity is a weak force. It works slowly, dragging atoms together over eons to build the swirling, majestic arms of a galaxy. For these structures to exist so soon after the beginning implies that they either grew at impossible speeds, or, and this is the terrifying part, the universe is actually far, far older than we think, and the beginning we calculated is a lie. According to the hierarchical assembly theory, which has been the Bible of galaxy formation for decades, the universe builds itself from the bottom up, like a child building a tower of blocks. It starts with small clumps of gas, which merge to form star clusters, which then slowly crash into each other over billions of years to form the large spiral and elliptical galaxies we see today. This process is messy, violent, and above all, incredibly slow. It requires the patience of deep time to sculpt structure out of chaos. But the data we are seeing now shows massive, discoid galaxies that are calm, orderly, and huge, sitting comfortably in an epoch where only chaos should exist. It is as if the universe skipped the construction phase entirely and simply appeared, fully formed and majestic, out of the vacuum. This suggests that our understanding of how matter interacts with gravity in the early universe is fundamentally flawed, or that there is a catalyst for creation that we have completely missed in our calculations, a hidden hand that stacks the blocks faster than the laws of physics should allow. The reaction within the scientific community has been less like a debate and more like a panic in a burning building, with papers being published with titles that actually include the word panic. This is not the measured, calm scientific method you see in documentaries. This is a scramble to save the foundation of modern physics before it collapses completely under the weight of the new data. Computer simulations that have run for months on supercomputers are now being thrown out because they cannot replicate the reality that the telescope is seeing. The models predicted a certain number of galaxies at these high redshifts, and the observations are finding 10, sometimes 100 times more mass than the simulations say is physically possible. When the map tells you there is a mountain and your eyes tell you there is an ocean, you don't redraw the ocean, you burn the map. We are currently standing with matches in our hands, looking at the map of the Big Bang, and wondering if we have the courage to light the fire that burns down a century of physics. In the shadows of this crisis, old, discarded theories are crawling back out of their graves. Zombie ideas that were once laughed at but now look terrifyingly plausible. One such theory is the tired light hypothesis, originally proposed by Fritz Zwicky nearly a century ago, which suggests that the universe isn't expanding at all. What if the redshift we see isn't caused by galaxies moving away from us, but simply by photons losing energy, getting tired as they travel across the vast, lonely distances of space? If this were true, it would mean the universe is not expanding. It is static, eternal, and infinite, with no beginning and no end. It would mean the Big Bang never happened, and we are living in a universe that has simply always been here, an eternal machine that grinds on forever. While this theory was dismissed decades ago, the new impossible data has forced astronomers to give it a second, terrified look, because a static universe would explain why those distant galaxies look so old. They are old, perhaps infinitely so. Then there is the even stranger and more vertigo-inducing concept of conformal cyclic cosmology, championed by the Nobel laureate Roger Penrose. This theory suggests that our Big Bang was not the beginning, but merely a beginning, one of an infinite series of bangs that occur in a never-ending cycle of death and rebirth. In this model, the universe expands until all matter decays into light, losing all concept of scale and time, at which point the geometry of the universe resets, triggering a new Big Bang. It implies that our universe is just one breath in an infinitely respiring cosmos, a single heartbeat in a body of reality that is beyond our comprehension. If Penrose is right, then the impossible structures we see might be the gravitational echoes of the universe that existed before ours, seeds planted in the dark soil of our reality by the death of the previous eon. We are not the first ones here. We are merely the latest tenants in a haunted house that has been built and destroyed countless times before. The most chilling implication of cyclic cosmology is the existence of what Penrose calls Hawking points, regions in our sky that might be the thermal ghosts of supermassive black holes from the previous universe. Imagine the horror of looking at the cosmic microwave background, the so-called baby picture of our universe, and realizing that the spots you see are not random fluctuations, but scars left over from an apocalypse that happened before time as we know it even began. These points would be evidence that information can actually survive the destruction of a universe, bleeding through the barrier of the Big Bang to contaminate our reality. It turns the sky into a graveyard, a memorial to a civilization or a physical reality that was wiped out to make room for us. It suggests that we are walking on the bones of a previous eternity, and that eventually, our universe will also die to become the ghost stories for the next cycle of existence. The problems with the standard model aren't limited to distant galaxies. Sometimes the call is coming from inside the house, right here in our own stellar neighborhood. We have found stars like the Methuselah star, or HD 140283, whose chemical composition suggests an age that is mathematically embarrassing for the Big Bang theory. Initial calculations dated this star at around 14.5 billion years old, which is problematic because the universe itself is supposedly only 13.8 billion years old. While refined measurements have brought the error bars down just enough to barely overlap with the age of the universe, the tension remains palpable and unsettling. How can a child be older than its mother? How can a star burn in a void that hasn't been created yet? It is a paradox that whispers a single, uncomfortable truth. Our timeline is wrong. Our clocks are broken, and the universe is hiding its true age from us, like a vanity-obsessed immortal. The cracks in the foundation continue to widen with the Hubble tension, a catastrophic discrepancy in our measurement of how fast the universe is actually expanding. We have two main ways to measure this expansion. One involves looking at the leftover radiation from the early universe, and the other involves looking at exploding stars in the modern universe. In a sane, logical reality, these two methods should give the same number, but they don't. They yield results that are statistically incompatible, differing by a margin that cannot be explained by measurement error. It is as if we measured a person's height with a tape measure and got 6 feet, then measured their shadow and calculated they must be 5 feet tall. Both measurements seem perfect, yet one reality must be a lie. This isn't just a math problem. It's a sign that we are fundamentally misunderstanding the geometry of space itself, or that the universe is changing its rules as it ages, playing a game with us that we haven't figured out how to play. To patch over these gaping holes in our understanding, scientists invented dark energy, a mysterious invisible force that supposedly makes up 68% of the universe and drives the accelerating expansion. But let's be honest with ourselves. We have never seen dark energy, we cannot measure it directly, and we have absolutely no idea what it is. It is a mathematical placeholder, a fudge factor inserted into the equations to make the answer come out right, much like medieval astronomers adding imaginary spheres to explain the movement of planets they didn't understand. We are claiming that the vast majority of reality is made of a substance we can't touch, taste, or see, simply because without it, our precious Big Bang theory falls apart completely. It is the ultimate scientific alibi, an invisible accomplice that can do whatever the laws of physics require to keep the theory alive, effectively insulating the model from falsification. The anomalies are not just in what we see, but in what we don't see. The vast, terrifying empty spaces known as cosmic voids, like the Boots void. This is a sphere of space nearly 330 million light-years across that is almost completely empty of galaxies, a darkness so profound that if the Milky Way were in its center, we wouldn't have known other galaxies existed until the 1960s. The standard model of the Big Bang simply does not allow enough time for gravity to clear out a space this massive. Moving that many galaxies out of such a huge region should take much longer than 13.8 billion years. These voids are the potholes on the road of cosmology, proving that the distribution of matter in the universe is far lumpier and more uneven than our smooth theories predict. It suggests that the universe has been churning and emptying itself for far longer than we admit, scrubbing vast regions of space clean in a process that requires an eternity we claim doesn't exist. If the Big Bang is indeed wrong, or at least significantly misunderstood, then the scale of the lie we have been living is almost impossible to quantify. Recent papers, such as those by physicist Rajendra Gupta, have proposed a hybrid model that stretches the age of the universe to a staggering 26.7 billion years, nearly double the current accepted age. Imagine the history of the Earth, the evolution of life, and the formation of stars, and then realize that we might have missed half of the story. This extra time would solve the problem of the impossible early galaxies by giving them billions of years to form, but it comes at a terrible price. It means throwing out the physics textbooks and admitting we have been looking at the universe through a distorted lens for a century. It means the timeline of reality is vast, deep, and frighteningly long, shrinking human existence from a brief flash to an imperceptible microsecond in the history of the dark. Gupta's theory is a Frankenstein's monster of physics, stitching together the expansion we think we see with Zwicky's discarded tired light theory to create a universe that fits the new data. It proposes that the fundamental constants of nature, the speed of light, the gravitational constant, the charge of an electron, might not be constant at all, but are actually evolving over time. This is a terrifying thought, because it means the laws of physics are not a solid bedrock, but shifting sand that changes beneath our feet as the eons pass. If the rules of the game change while you are playing it, how can you ever hope to win? It suggests that reality itself is fluid, mutating as it ages, and that what we measure today might be completely different from what was true a billion years ago. We are trying to build a house on a foundation that is slowly sliding into the sea of time. The philosophical horror of abandoning the Big Bang is profound because the Big Bang gave us a narrative arc, a birth, a life, and an eventual death of the universe. It was a story that made sense to the human mind, which is obsessed with beginnings and endings. But if we revert to a steady state or an infinite timeline, we are faced with the terror of the eternal, a universe that has no purpose, no direction, and no destination. It simply is a grinding, uncaring machine that exists for no reason and will never stop existing, trapping us in an infinite loop of existence. This removes the specialness of our moment in time. We are not the children of a grand creation event, but merely dust motes floating in a room that has never been cleaned and will never be closed. It forces us to confront the possibility that existence is not a journey, but a static, terrifyingly permanent state of being. The forensic evidence against the standard model continues to mount with the existence of the CMB cold spot, a massive region of the sky that is significantly colder than the rest of the cosmic microwave background. According to the standard theory, the early universe should be incredibly uniform, with temperature variations of only 1 part in 100,000. Yet here is a giant bruise on the face of the cosmos that statistics say should not exist. Some physicists have suggested this cold spot is the result of a collision with another universe entirely, a multiverse bruise where another bubble of reality bumped against ours, leaving a permanent scar. If true, this means our universe is not an isolated island, but one bubble in a boiling cosmic foam, constantly jostled and battered by other realities that we can never see or touch. We are not alone in the void. We are crowded in the dark with other universes, and sometimes we crash into them. This leads us to the concept of brane cosmology, which posits that our entire three-dimensional universe is just a membrane floating in a higher dimensional bulk, like a sheet of paper floating in a room. In this terrifying vision, the Big Bang was not a creation event from nothing, but the result of two of these membranes colliding, a clash of titans in the fourth dimension that released the energy we call our universe. If this is true, then the bang can happen again at any moment. Another membrane could drift through the higher dimensions and slam into us, resetting our reality in an instant of unimaginable destruction. We are like ants living on a leaf, completely unaware of the wind that is about to blow us into another world. It reframes our origin not as a miracle, but as a traffic accident in a hyperdimensional highway that we lack the sensory organs to perceive. Then there is the horizon problem, a mystery that keeps cosmologists awake at night staring at the ceiling. If you look at the cosmic microwave background, the temperature is almost exactly the same on opposite sides of the sky, regions that are separated by nearly 28 billion light-years. The problem is that there has not been enough time since the birth of the universe for light or information to travel from one side to the other to equalize the temperature. They should be complete strangers to each other. It is like finding 2 cups of coffee on opposite sides of the planet that are the exact same temperature to the millionth of a degree. It implies they were once in the same pot, mixed together. To fix this, we invented inflation, a period of faster-than-light expansion, but even the creators of inflation admit it is a patch, a band-aid applied to a theory that is bleeding out. It explains the uniformity, but the mechanism that started it and stopped it remains a mystery wrapped in an enigma. Inflation theory itself carries a seed of nightmare logic known as eternal inflation. The math suggests that once this rapid expansion starts, it never really stops everywhere at once. It stops in patches, creating pocket universes like ours, while the rest of the fabric of space continues to inflate forever. This means that the multiverse is not just a possibility, it is an inevitability of the theory we use to save the Big Bang. We are living in a small, stable bubble of calm, in an ocean of eternally exploding space, a temporary sanctuary that is surrounded by chaos. If this is true, then everything that can happen is happening somewhere in the infinite fractal of inflating space. It renders our existence statistically insignificant, turning our entire observable universe into a microscopic flaw in a diamond of infinite growth. It is a theory that solves one problem by creating an infinity of others, drowning us in a sea of unobservable worlds. The chemical fingerprint of the universe also tells a story that contradicts the official report, specifically regarding the element lithium. The Big Bang model makes very precise predictions about how much hydrogen, helium, and lithium should have been cooked up in the first few minutes of the cosmic oven. We have found the hydrogen and the helium, but the lithium is missing. Specifically, there is 3 times less lithium-7 in the oldest stars than the theory predicts. This lithium problem is not a small rounding error. It is a glaring hole in our understanding of nuclear physics in the early universe. Where did it go? Did it decay? Was it never there? Or is our model of the cosmic oven fundamentally broken? It's like following a recipe perfectly, but ending up with a cake that is missing a key ingredient. It proves that either the recipe is wrong, or someone came into the kitchen and stole the ingredients while we weren't looking. Perhaps the most suspicious piece of evidence is the flatness problem. Measurements show that the geometry of our universe is perfectly, terrifyingly flat, meaning parallel lines stay parallel forever and triangles add up to exactly 180 degrees. For this to happen by chance in the Big Bang, the initial density of the universe had to be fine-tuned to an accuracy of 1 part in 10 to the power of 62. If it had been slightly different, the universe would have either collapsed instantly into a black hole or flown apart so fast that no atoms could form. This level of precision is so unnatural that it screams of artificiality. It is like balancing a pencil on its tip and having it stay there for 14 billion years. It suggests that the conditions of our reality were set with a dial, calibrated to a razor's edge of stability, which naturally leads to the unsettling question, who or what set the dial? But nothing terrifies the strict materialist more than the axis of evil. When we analyze the fluctuations in the cosmic microwave background, we find a strange alignment, a preferred direction that lines up uncannily well with the plane of our own solar system. In a random, chaotic Big Bang universe, there should be no up, down, or center. The universe should look the same in all directions. But the data suggests a pattern that is aligned with us, with Earth. This hints at a return to a form of geocentrism that science spent 500 years trying to destroy. It implies that we are seemingly at a special place in the cosmos, or that the data is being corrupted by something local. If it's not a measurement error, it breaks the Copernican principle, the idea that we are not special, and suggests that the universe has a structure that is intimately tied to our specific viewpoint. It is a ghost in the machine of data that shouldn't be there. This alignment is so disturbing that many scientists simply refuse to talk about it, dismissing it as a statistical fluke, a ghost in the data processing. But what if it isn't? What if the universe actually has a north and south pole, an orientation that defies the isotropic model we rely on? If the Copernican principle falls, if we are indeed in a special or central location, then all of our calculations about distance, redshift, and the age of the universe are based on a false assumption. It would mean we are analyzing the cosmos from a privileged, unique vantage point that distorts the data, like trying to map a forest while standing in a hall of mirrors. The implications are theological as much as they are scientific, threatening to undo the humility that science has forced upon humanity since Galileo looked through his telescope. It is the ultimate forbidden thought in physics that maybe, just maybe, the universe is watching us back. And what of dark matter, the other invisible ghost we summoned to save our gravity equations? We invented it because galaxies spin too fast. Without extra invisible mass, the stars at the edges should fly off into deep space like water from a spinning tire. But despite decades of searching with sensitive detectors buried deep underground, we have never found a single particle of dark matter. This failure has given rise to MOND, modified Newtonian dynamics, a theory that suggests there is no invisible matter, but rather that our understanding of gravity itself is wrong. Perhaps gravity behaves differently on the scale of galaxies than it does in our solar system. If MOND is right, then general relativity, Einstein's masterpiece, is incomplete or flawed. We are clinging to the idea of dark matter because the alternative is admitting that we don't understand the fundamental force that holds the universe together. We are inventing ghosts to explain why the floorboards are creaking. Lurking on the fringes of cosmology is the plasma universe theory, which argues that we have overestimated gravity and underestimated electromagnetism. In this view, the universe is not a collection of heavy rocks orbiting each other, but a vast, interconnected web of electrical currents and plasma filaments stretching across billions of light years. If the universe is electric, then the Big Bang wasn't an explosion of matter, but a short circuit, a discharge event in a pre-existing medium. While mainstream science largely rejects this, the visuals of the cosmic web look suspiciously like neural networks or lightning bolts, hinting that the forces shaping the large-scale structure of the universe might be more like a storm than a clock. It paints a picture of a volatile high-voltage reality, where galaxies are merely light bulbs plugged into a cosmic grid we cannot see. The breakdown of the Big Bang model also fuels the simulation hypothesis, the idea that the reason our physics is glitching is that we are reaching the limits of the system's processing power. When a video game tries to render objects that are too far away or too complex, it creates artifacts, glitches, and simplified textures to save memory. The impossible galaxies, the pixel-like limits of the Planck length, the maximum speed of light, these could be the constraints of the hardware running our reality. If the universe is a simulation, then the Big Bang was simply the moment the boot-up sequence completed and the program began running. The anomalies we see are not mysteries of nature, but rendering errors, signs that the computer is struggling to maintain the illusion of a consistent history for the observers inside the code. This brings us to the Planck length, the absolute minimum unit of size in the universe, below which physics as we know it ceases to exist. It acts suspiciously like a pixel size for reality, a hard limit on resolution that implies space is not continuous, but discrete. If space is pixelated, then the smooth expansion of the Big Bang is a lie. The universe expands in jumps, in clicks of the cosmic clock. The blurriness of the early universe data might not be due to gas or dust, but simply because we are zooming in too far on a JPEG that doesn't have enough resolution to show us the truth. We are trying to read the source code of the cosmos, but we are hitting the encryption wall that hides the operating system from the user. While we debate the beginning, something is happening right now that suggests we don't understand the current motion of the universe either. We are being pulled towards a gravitational anomaly known as the Great Attractor, a region of space obscured by the Milky Way's own dust. Everything in our supercluster, millions of galaxies, including us, is flowing towards this point at millions of miles per hour. But when we look past it, we see an even larger monster, the Shapley supercluster. We are seemingly sliding down a gravitational drain into a region of space so dense that it dominates the motion of our entire local universe. It suggests a structure to the cosmos that is far more complex than a simple uniform expansion. It is a river, and we are caught in the current, heading towards a waterfall we cannot see. But it gets stranger. Not only are we being pulled by the attractor, but we are also being pushed by a void known as the dipole repeller. This creates a push-pull effect that is accelerating our galaxy through space faster than gravity alone should allow. It implies that the empty regions of space are not just passive vacuums, but active participants that exert a repellent force on matter. The universe is a dynamic engine of flows and currents pushing and pulling galaxies around like ships in a storm. This complex choreography of motion contradicts the simple balloon expanding analogy of the Big Bang, replacing it with a turbulent ocean of forces where void and matter fight a war for territory. And beyond even the Great Attractor lies the mystery of the dark flow. Astronomers have detected a coherent motion of galaxy clusters millions of light-years across, all streaming towards a specific patch of sky between the constellations of Centaurus and Hydra. The terrifying part? The source of this pull seems to be something outside the observable universe. This flow shouldn't exist in the standard Big Bang model, which predicts a random distribution of motion. Instead, it looks like something massive, something beyond the edge of our visible map, is dragging a chunk of our universe towards it. It is the first tangible evidence that there is a beyond, a structure larger than our universe that is exerting influence on us, pulling us into the unknown like water down a plug hole. What could possibly be big enough to pull millions of galaxies across the cosmos? Some theorize it is the gravitational tug of a neighboring universe, a sibling bubble, that is close enough to ours to be felt but not seen. Others fear it is a concentration of matter so dense that it defies physics, a hypermass left over from a time before inflation. Whatever it is, it proves that the edge of the observable universe is not the edge of reality. There are monsters in the dark beyond the campfire light of our telescopes, and they are reeling us in. We are not drifting aimlessly. We are being hunted by gravity itself, pulled towards a destination that sits outside of time and space as we understand it. The deeper we look, the more the fine-tuning problem mocks the idea of a random Big Bang. If you change the strength of the strong nuclear force by just 2%, stars would never burn. If you change the strength of gravity by a hair, the universe either collapses or freezes. The constants of nature are tuned with a precision that makes a Swiss watch look like a pile of junk. The Big Bang Theory says this is just luck, a roll of the dice in a single event. But the odds of hitting this jackpot are so infinitesimally small that it suggests the game is rigged. Either there are infinite universes and we are the winners of a cosmic lottery, or the parameters were set by a mechanism we haven't discovered, a mechanism that implies intent, or at least a selection process that favors existence over nothingness. This improbability leads to the terrifying concept of the Boltzmann brain. According to the laws of entropy and quantum fluctuation, it is actually statistically more likely for a single, fully formed brain to spontaneously hallucinate this entire universe for a split second than for the Big Bang to create a real, consistent universe that lasts for billions of years. If we rely purely on randomness, you are likely the only thing that exists, a momentary flicker of consciousness in the void dreaming up these words, these stars, and this history. The Big Bang Theory fights this solipsistic nightmare, but as the theory weakens, the Boltzmann brain waits in the wings, whispering that reality might be a lonely, momentary delusion of a mind formed from chaos. The entropy problem is the arrow of time itself. The universe started in a state of extremely low entropy, high order, high organization, and has been getting messier ever since. But in a natural explosion, things start messy and get messier. For the Big Bang to produce a low-entropy start is like setting off a stick of dynamite in a library and having all the books land in perfect alphabetical order on the shelves. It violates the intuition of chaos. This initial state of order is so unlikely that Penrose calculated the odds at 1 in 10 to the power of 10 to the power of 123. That number is so big you couldn't write it down if you used every atom in the universe as a pen. It suggests that the beginning wasn't an explosion but a careful, deliberate placement of matter in a highly specific arrangement. Is it possible that we are misinterpreting the very nature of where we are? Some physicists have proposed black hole cosmology, the idea that our universe is actually the interior of a supermassive black hole existing in a larger parent universe. The math of the event horizon, the point of no return, surprisingly matches the description of the edge of our observable universe. In this scenario, the Big Bang was simply the moment the black hole formed in another dimension, and we are the matter that got swallowed, now living out our lives inside the singularity. The expansion we see is just the black hole growing as it eats more matter from the outside. We are looking for the exit, but we are already trapped in the belly of the beast. Even stranger is the holographic principle, which stems from string theory. It suggests that all the information in our 3D universe is actually encoded on a 2D surface at the boundary of the cosmos. Everything we see, touch, and feel is a holographic projection of this data. If this is true, the Big Bang wasn't a physical explosion of space, but an explosion of information the moment the projector turned on. It implies that volume, depth, and distance are illusions created by the processing of this surface data. We are characters on a screen believing we have depth, while the true reality is flat, written on the walls of the universe's edge. It turns cosmology into a branch of information technology. Let's return to the immediate evidence, to the universe breakers that JWST found. These galaxies are not just old, they are incredibly dense. Imagine taking all the stars in the Milky Way and crushing them into a ball the size of a golf course. That is the density we are talking about. The Big Bang model predicts that early galaxies should be diffuse, fluffy clouds of gas slowly collapsing. These objects are compact, hard, and bright. They look like the cores of ancient galaxies that have been stripped of their outer layers. How could the universe produce old cores at the very beginning? It's like finding a fossil in a rock that just cooled from lava 5 minutes ago. The timeline is hopelessly compressed, and the pressure is cracking the theory apart. The emotional toll on the scientists is real. Astronomer Alison Kirkpatrick was famously quoted saying, "Right now I find myself lying awake at 3 in the morning wondering if everything I've done is wrong." This isn't hyperbole. It's the sound of a paradigm shifting. Careers, textbooks, and reputations have been built on the Big Bang. To admit it might be wrong is to admit that we have been teaching a myth for decades. The data is not just numbers. It's a wrecking ball hitting the ivory tower of academia. The sleepless nights are filled with the realization that the universe is far more alien than the comfortable equations predicted. The panic is palpable because the unknown is rushing back in to fill the void left by the collapsing theory. Thomas Kuhn, the philosopher of science, famously said that scientific revolutions don't happen by consensus, but by funerals. The old guard has to die off before the new ideas can take root. We are in the middle of such a revolution. The defenders of the Big Bang are fighting hard, proposing tweaks and patches to save the model, but the universe breakers are relentless. Every new image from deep space acts as another nail in the coffin of the standard model. We are witnessing the death of a worldview in real time, a rare and violent event in the history of human thought. The transition from the Big Bang is truth to the Big Bang is a myth will not be smooth. It will be a war of ideas fought in journals and conferences, with the nature of reality as the prize. In the desperate search for answers, some have turned to the mirror universe theory. This proposes that the Big Bang created two universes, ours, which moves forward in time, and a mirror universe made of antimatter that moves backward in time. In that other realm, time flows from our future to our past. It balances the equations of symmetry perfectly. If this is true, there is another you, moving backwards through time on the other side of the Big Bang. It sounds like science fiction, but it solves the problem of where all the antimatter went. It suggests that the Big Bang wasn't a start, but a reflection point, a mirror in the center of eternity where two realities diverge. Even more exotic is the concept of tachyon instability. Tachyons are hypothetical particles that travel faster than light. If they existed in the early universe, they would violate causality, the rule that cause must come before effect. In a tachyon-dominated universe, the future can affect the past. The universe could have created itself after it began. It's a headache-inducing loop that destroys the linear timeline the Big Bang relies on. If the early universe was filled with these particles, our concept of time zero becomes meaningless. The universe didn't begin. It emerged from a loop of time where the end wrote the beginning. And we cannot forget the threat of vacuum decay. The Big Bang might have left the universe in a metastable state, a false vacuum. Imagine standing on a ledge, thinking it's the bottom of the valley, but there is a deeper drop hidden in the fog. If a bubble of true vacuum were to appear anywhere in the cosmos, it would expand at the speed of light, rewriting the laws of physics and deleting everything in its path. We wouldn't see it coming, we would just cease to exist. If the Big Bang established this fragile state, then our entire existence is a precarious balancing act that could end without warning, proving that the creation event was flawed from the start. Ultimately, the Big Bang fails to answer the most haunting question of all. Why is there something rather than nothing? It explains the expansion, but not the origin of the energy itself. It kicks the can down the road. But if the Big Bang is wrong and the universe is eternal, the question changes. It's no longer how did it start, but why does it exist at all? An eternal universe is a brute fact, a monster that requires no creator and no origin. It forces us to confront the idea that existence is a default state, which is somehow more terrifying than a creation event, because it implies there is no way out of the system. This shift in timeline also crashes into the Fermi paradox, the question of where is everybody? If the universe is only 13.8 billion years old, maybe we are the first civilization. But if the universe is 26 billion years old, or infinite, The silence of the sky becomes a deafening scream. An older universe means that alien civilizations have had double the time to rise, spread, and conquer the stars. Their absence is no longer a puzzle, it is a warning. It suggests that something kills civilizations before they can spread. The older the universe, the more efficient the killer must be. The silence tells us that the cosmos is a graveyard, and we are just the latest tombstone being carved. This great filter might be the universe itself. If the cosmos is cyclical or volatile, perhaps civilizations get wiped out by regular cataclysms, vacuum decay, brain collisions, or black hole resets, before they can become gods. We might be living in a brief window of stability between cosmic storms. The fact that we see no one else suggests that long-term survival is impossible. We are like a mold growing on a sandwich in the brief time before the refrigerator light goes off. The new cosmology doesn't just change the age of the stars, it changes the odds of our survival. Consider the theory of primordial black holes. These are black holes that formed not from dying stars, but from the dense soup of the Big Bang itself. If they exist, they could be the dark matter we can't find. But they would also be time bombs ticking since the dawn of creation. They could be wandering through our solar system right now, invisible and deadly. If the universe is older, these monsters have had more time to grow and merge. We might be surrounded by invisible mouths that have been eating the universe since before the first star ignited. Between the hypothetical Big Bang and the formation of the first stars lies the cosmic dark ages. This is a period we cannot see with light, a curtain drawn across history. We assume it was simple hydrogen gas, but if the Big Bang is wrong, the dark ages might have been filled with exotic physics, ancient populations of stars, or structures we can't imagine. It is the missing pages of the history book. What happened in the dark? Did other universes rise and fall in the billions of years we assumed were empty? The curtain is hiding something, and JWST is trying to peek behind it. The battle is raging in the peer-reviewed journals right now. Papers are being published claiming the standard model is dead, while others desperately try to resuscitate it with complex mathematics. It is a chaotic, intellectual war zone. One side argues that we just need to tweak the parameters. The other side argues that the entire machine is broken. This is not a polite disagreement. It is a fight for the soul of science. Every new data point is a weapon. We are watching the scientific method in its rawest, most violent form, stripping away the comfortable lies to reveal the jagged truth underneath. We are standing on the precipice of a new dark age of knowledge. Not an age of ignorance, but an age where we realize how little we actually know. The comfortable map is burning. The compass is spinning wild. We are realizing that the universe is larger, older, and stranger than our brains are evolved to comprehend. As we move forward in this investigation, we must be willing to let go of the safety of the Big Bang and step into the void of the unknown. What we find next might rewrite not just the history of the universe, but the future of humanity itself. To truly grasp the magnitude of our ignorance, we must confront the cosmological constant problem, often cited as the single worst prediction in the history of physics. According to quantum field theory, the vacuum of space is not empty. It is seething with virtual particles popping in and out of existence, a quantum foam of energy. When we calculate the energy density of this vacuum, using our best understanding of quantum mechanics, we get a number that is colossal, a number that represents the energy of the void itself. But when we look at the actual universe and measure how fast it is expanding, which should be driven by this energy, we find a value that is infinitesimally small. The discrepancy between the theoretical prediction and the observed reality is not a factor of 2 or 10. It is a factor of 10 to the power of 120. This is a 1 followed by 120 zeros. It is a mistake so large that it suggests we know absolutely nothing about the fundamental nature of the vacuum we live in. Let's visualize that error. If you were to calculate the mass of the entire observable universe, every star, every galaxy, every black hole, and you missed by a factor of 10 to the power of 120, you wouldn't just be off by a few stars. You would be off by a number greater than the number of atoms in the universe itself. It is a catastrophic failure of theory. If the quantum prediction were true, the universe should have ripped itself apart in a fraction of a microsecond after the Big Bang. The repulsive force would have been so strong that no atom could have ever formed. The fact that we exist at all means that either our quantum mechanics is broken, or there is some magical cancellation mechanism, accurate to 120 decimal places, that we haven't found yet. We are existing in the slim margin of error of a calculation that says we should be dead. This discrepancy isn't just a numbers game, it's a sign that general relativity, the physics of the huge, and quantum mechanics, the physics of the tiny, are fundamentally incompatible. We have been trying to force them into a marriage for a century, and the result is a broken home. The Big Bang singularity is the point where these two theories crash into each other and break down. At the moment of the bang, the universe was both tiny quantum and massive relativity. Because our math fails at this intersection, we literally cannot describe the beginning. We are using a map that has a blank spot exactly where the "you are here" pin should be. We talk about the first second, but in reality, our equations dissolve into nonsense before we get there. We are building a history on a foundation of mathematical gibberish. The tension has become so unbearable that in 2024, the Royal Society in London convened a meeting titled "Challenging the Standard Model." This wasn't a gathering of fringe conspiracy theorists in a basement. This was the elite of the scientific world gathering in the halls of Newton and Darwin to admit that the wheels are coming off the bus. The mood was somber. Professor Sabir Sarkar from Oxford stood up and argued that our assumption of an isotropic universe, one that looks the same in all directions, is simply not supported by the data. If the universe isn't isotropic, then dark energy doesn't need to exist. It's just a mathematical artifact of us being in a weird location. To hear leading physicists openly discuss dismantling the Standard Model is like hearing the cardinals in the Vatican discuss the possibility that God might not be watching. There is a sociological horror here as well: the file drawer effect. For decades, young astronomers who found data contradicting the Big Bang were told to check their numbers again, or worse, their papers were rejected because, quote, "extraordinary claims require extraordinary evidence." How many anomalies were shoved into a file drawer and forgotten because they didn't fit the narrative? We have constructed a reality based on confirmation bias, filtering out the ghosts because they scared us. Now, the drawer is bursting open and all the rejected data is spilling out onto the floor. We are realizing that we may have bullied the truth into silence because it was too uncomfortable to face. The universe didn't lie to us. We lied to ourselves to feel safe. One of the alternative theories fighting for air is MOND, modified Newtonian dynamics. Proposed by Mordechai Milgram, it suggests that we don't need dark matter to explain why galaxies spin so fast. Instead, it posits that gravity behaves differently at extremely low accelerations. In our solar system, gravity is strong, and Newton's laws work. But in the ghostly outskirts of a galaxy, where gravity is a whisper, MOND argues the rules change. If MOND is right, there is no invisible matter. There is just a misunderstood force. It implies that gravity is not a constant, rigid law, but a flexible, changing field. This is terrifying because it means the universal law of gravitation is not universal at all. It's a local ordinance, effective only in our backyard, while the deep cosmos operates under a completely different legal system. The battlefield where MOND and dark matter fight to the death is the bullet cluster. This is a massive collision between two galaxy clusters, where the gas has slammed together and stopped, but the mass, detected by gravitational lensing, seems to have kept moving. Dark matter proponents cheer, saying this proves the invisible matter, separated from the visible gas. But MOND proponents argue that even this can be explained with modified gravity if you add neutrinos to the mix. It is a cosmic wrestling match where both sides claim victory, but the audience, humanity, is left in confusion. The fact that we look at the most violent collision in the universe and can't agree on what we are seeing proves how blind we truly are. We are watching shadows on a cave wall and arguing about the monsters casting them. Then there is El Gordo, the fat one. This is a galaxy cluster weighing 3 quadrillion times the mass of our Sun, sitting at a redshift that places it 7 billion years in the past. The problem? It is too big, too early. According to the Standard Model of structure formation, collisions this massive shouldn't have happened yet. It's another impossible object, a leviathan swimming in a pond that should only hold minnows. The existence of El Gordo suggests that the early universe was a place of titanic violence and rapid growth that our computer models simply cannot replicate. Something was accelerating the growth of these monsters, feeding them mass at a rate that defies the speed limit of gravity. It forces us to ask, what was feeding the monsters? If dark energy is real, and it is accelerating the expansion of the universe, we face the ultimate existential horror, the Big Rip. As the expansion gets faster, it eventually overcomes gravity, tearing apart galaxies. Then it overcomes electromagnetism, tearing apart solar systems and planets. Finally, it overcomes the strong nuclear force, ripping apart the atoms in your body. In this scenario, the universe doesn't just end, it is shredded. Space itself becomes a torture rack, stretching every particle until it snaps. This isn't science fiction. It is a very real solution to the equations we are currently using. If the Big Bang was the birth, the Big Rip is the execution, and the executioner is the very vacuum of space we are floating in. The phantom energy driving the Big Rip implies that the density of dark energy increases over time. This violates the conservation of energy, a rule we thought was sacred. It means the universe is a runaway engine, creating energy out of nothing to destroy itself. The timeline for this is debatable, but the mechanism is sound. Imagine looking up at the sky and seeing the stars drifting away one by one, then the sun, then the moon, until finally your own hand dissolves into radiation. It is the ultimate isolation, a universe that pulls everything away from everything else until every particle is alone in the infinite dark. It is a lonely, violent death for reality. Compare this to the Big Crunch, the old favorite theory where gravity wins and the universe collapses back into a singularity. That offered a cycle, a rebirth, or the Big Freeze, where we just drift apart and cool down forever. But the Big Rip is new, born from the discovery of acceleration in the 1990s. It is the most violent of the endings, and ironically, it fits the violent, impossible data we are seeing from JWST. If the early universe was more explosive than we thought, perhaps the end will be too. Nature tends to symmetry. A violent birth begets a violent death. We wanted a peaceful fade to black, but the universe seems intent on going out with a scream. This brings us back to Roger Penrose's aeons. If the Big Bang is wrong, and the universe is cyclic, then what we call the Big Rip might actually be the clearing of the slate for the next Big Bang. Penrose argues that in the far future, when all matter has decayed into radiation, the universe loses track of time and size because photons don't experience time. In that state of infinite expansion, the geometry becomes mathematically identical to the singularity of a Big Bang. The end is the beginning. We are trapped in an Ouroboros, a snake eating its own tail. While this grants us immortality of a sort, it is a hellish immortality, an endless repetition of the same mistakes, the same wars, the same cosmic tragedies, playing out over and over forever. The information paradox of black holes is another clue that our reality is not what it seems. Stephen Hawking famously realized that black holes radiate energy and eventually evaporate. But if a black hole disappears, what happens to the stuff that fell in? Quantum mechanics says information can never be destroyed, but relativity says a black hole destroys everything. This conflict is a crack in the windshield of physics. If information is lost, then the past is not fixed. History can be deleted. If information is preserved, then the universe is a hologram, where the 3D object is just a projection of 2D data smeared on the event horizon. Either way, the solid, reliable world you think you live in is an illusion. The holographic principle is not just a wild guess. It is the only way to make the math of black holes work. It suggests that the pixels of our reality are Planck-sized squares on the boundary of the cosmos. This means you, me, the Earth, and the stars are essentially software running on a hard drive located at the edge of the universe. We are shadows, thinking we are the object. If the Big Bang was the boot-up of this hologram, then the anomalies we see, the glitches in the early universe, might be artifacts of the projection code. We are trying to find physical explanations for what are essentially digital errors in the cosmic operating system. Let's reconsider the mirror twin hypothesis. In the lambda-CDM model, we assume symmetry. Some physicists argue that for every particle of matter created in the Big Bang, a particle of antimatter was created. But we don't see the antimatter. Where is it? The mirror universe theory suggests it is moving backwards in time from the Big Bang. But this implies that our future is their past. It suggests a terrifying symmetry where our actions are mirrored or balanced by a shadow self in a shadow world. Are we the original, or are we the reflection? If we are the reflection, then our beginning was actually their end. We are walking backwards into the future, blind to where we came from. The axis of evil in the cosmic microwave background refuses to go away. This alignment of hot and cold spots with the plane of our solar system is the ghost that haunts the Copernican principle. Copernicus taught us that we are not special, that we are just a rock orbiting a generic star in a generic galaxy. But the universe seems to be pointing a finger right at us. If this alignment is real, it overturns 500 years of science. It suggests that the large-scale structure of the cosmos is somehow correlated with our tiny, insignificant home. It brings back the uncomfortable feeling of being watched, of being center stage in a theater we thought was empty. Statistically, the odds of the axis of evil happening by pure chance are less than 1 in 1,000. In any other field of science, a result like that would be considered proof of a connection. But in cosmology, it is so terrifying that we dismiss it as bad luck. We invoke the look elsewhere effect, claiming that if you look for enough patterns, you will find one. But this pattern is aligned with us. It is like shuffling a deck of cards and dealing out your own phone number. You can call it coincidence, but deep down you know the deck is rigged. The universe is showing us a pattern we are too afraid to accept. The cold spot in the CMB is another anomaly that the Big Bang can't explain. It is a region 1.8 billion light-years across where the temperature drops significantly. It is a void, a supervoid, but it is too big and too cold to be natural. Some theories suggest it is the imprint of a collision with a bubble universe. Imagine our universe as a soap bubble floating in air. If another bubble hits us, it leaves a dent. The cold spot might be that dent. It is direct evidence that the multiverse is not just a theory but a crowded room where we are bumping elbows with other realities. What physics operates inside that bruise? If we traveled there, would the laws of nature still apply? While we look back at the beginning, we are being dragged forward by the dark flow. Clusters of galaxies are moving at 2 million miles per hour towards a patch of sky between Centaurus and Hydra. This motion is distinct from the expansion of the universe. It is a river. And the scary part? The drain they are flowing towards is outside the observable universe. We can't see what is pulling us, but we can feel the tug. It implies that the structure of the universe continues beyond the horizon of light, and whatever is out there is massive enough to drag our entire reality towards it. We are flotsam in a current, heading for a waterfall hidden in the dark. Pulling the strings of our local group is the Shapley supercluster, the largest concentration of galaxies in our nearby universe. It is a monster of gravity, a city of stars so dense it warps the space around it. But even Shapley is being pulled. The chain of gravity goes on and on. We are part of a filament, a strand in a web, being reeled in by a fisherman we cannot see. The Big Bang model assumes a uniform distribution, a smooth sea. But we are finding currents, whirlpools, and monsters that suggest the ocean is far more treacherous than we were told. And pushing us from behind is the dipole repeller. We are not just falling, we are being chased. There is a region of space so empty that it effectively repels matter, creating a push-pull dynamic with the Shapley attractor. This void is a ghost town of the cosmos, a place where gravity has failed. The fact that nothingness can exert a force is a concept that breaks the intuition of the Big Bang. It means the voids are active participants in the evolution of the universe, expanding bubbles of emptiness that shove galaxies around. We are running away from the dark as much as we are running towards the light. When we map the large-scale structure of the universe, we see the cosmic web. Filaments of dark matter and gas stretch across billions of light-years, connecting galaxy clusters like nodes in a network. It looks eerily biological. It looks like a neural network. It looks like a brain. This visual similarity has spawned the cosmic brain hypothesis. Is the universe a single, vast information processing system? Are galaxies the neurons and dark matter the axons? If so, the Big Bang wasn't an explosion. It was the waking up of a mind, and we are just subatomic particles in the thoughts of a God-sized entity. In 2020, an astrophysicist and a neuroscientist published a paper comparing the network of the human brain to the cosmic web. The statistical similarities were shocking. The connectivity, the clustering, the ratio of mass to energy, it all aligned. The micro reflects the macro. As above, so below. This isn't just poetry, it's a structural reality. If the universe is a neural network, what is it thinking? Are the anomalies we see, the impossible galaxies, the cold spots, actually thoughts, memories, or perhaps a stroke? A glitch in the firing of the cosmic neurons. We might be living inside a mind that is slowly losing its sanity. This leads to panpsychism, the ancient idea that consciousness is a fundamental property of matter, like mass or charge. If the universe is structured like a brain, perhaps it possesses a form of consciousness we cannot comprehend. The fine-tuning of the universe might not be luck, it might be choice. The universe might be adjusting its own constants to maximize the growth of complexity. Just as a brain creates new connections to learn, we are not observers of a dead mechanism. We are parts of a living, thinking organism that is evolving in real time. The Big Bang was just the first thought. Taking this further, the self-simulation hypothesis by quantum gravity research suggests the universe is a strange loop that simulates itself into existence. It uses a code based on the E8 Lie group geometry to project reality. In this model, the future can affect the past because the simulation optimizes itself for consistency. The impossible galaxies found by JWST are retrocausal corrections, the code patching itself to ensure that life, the observer, eventually emerges. We are not discovering the past. We are solidifying it by looking at it. The act of observation is the act of creation. This brings the observer effect from quantum mechanics to the cosmic scale. In the double-slit experiment, a particle doesn't choose a path until it is measured. Does the universe exist in a superposition of all possible states until a conscious observer looks at it? Did the early universe exist in a quantum fog until we built the James Webb telescope and collapsed the wave function? This would explain why we see things that shouldn't be there. Our expectation of seeing something forced the universe to render something even if it violates the laws of physics. We are the glitch in the matrix. John Wheeler, the legendary physicist, called this the participatory universe. He visualized it as a U with an eye at one end looking back at the beginning. We are the universe looking at itself. By looking back at the Big Bang, we are participating in the act of creation. We are closing the loop. This means the history of the universe is not fixed. It is fluid, waiting for us to discover it. The proof that the Big Bang is wrong might be appearing now simply because we are finally looking for it. We are writing the history book as we read it. Retrocausality is the most headache-inducing concept in physics, but the delayed choice quantum eraser experiment proves it is real on a small scale. Decisions made in the present can affect the past state of a particle. If this applies to the cosmos, then turning on JWST might have actually caused the formation of those early galaxies billions of years ago. We are sending a causal ripple back through time. The universe is ensuring its own consistency by planting the evidence we are looking for. It's a terrifying thought, that we are responsible for the chaos we are discovering. The Goldilocks enigma of fine-tuning remains the strongest argument against a random Big Bang. The ratio of the electromagnetic force to gravity, the mass of the electron, the cosmological constant, change any of these by a hair, and the universe is dead. A random explosion doesn't result in a Swiss watch. Science tries to explain this with the multiverse. If there are infinite universes, one has to be right. But that is a cop-out. It is an admission of defeat. It creates an infinity of unobservable ghosts. To explain the one reality we see, it is faith, not science. The multiverse theory is the ultimate get-out-of-jail-free card for cosmologists. The Big Bang doesn't fit the data? Just say this is a weird universe among infinite others. It makes the theory unfalsifiable. You can explain anything with infinite possibilities. But a theory that explains everything explains nothing. If we resort to the multiverse to save the Big Bang, we have left the realm of empirical evidence and entered the realm of metaphysics. We are no longer doing physics. We are telling bedtime stories to comfort ourselves in the dark. The Boltzmann brain paradox returns to haunt us here. In an infinite multiverse, It is infinitely more likely for a single brain to fluctuate into existence with false memories of a Big Bang than for a real Big Bang to occur. If you accept the multiverse to save the Big Bang, you must statistically accept that you are likely a hallucinating brain in a void. The logic eats itself. The tool used to save the theory destroys the reality of the observer. It forces us to question if reality is even a coherent concept. Let's look at the concept of nothing. The Big Bang supposedly came from nothing. But in quantum physics, nothing is highly unstable. Heisenberg's uncertainty principle forbids a perfect vacuum because a perfect vacuum has a known energy, 0, and a known position, which is impossible. So nothing must boil with energy. This means the universe didn't come from nothing. It came from a fluctuating potential. Existence is the inevitable result of the instability of non-existence. We are here because nothing is too unstable to stay nothing. These virtual particles are not just theory. We see their effects. They drive the forces that hold your atoms together. But they also imply that the vacuum has a weight, a pressure. If the vacuum energy calculation is wrong, the 120 orders of magnitude error, then maybe the vacuum isn't what we think it is. Maybe space is a superfluid, a physical substance like water, and we are fish swimming in it unaware of the water. The Michelson-Morley experiment supposedly disproved the ether, but modern quantum vacuum looks suspiciously like the ether returned in a disguise. The Casimir effect proves that empty space can push metal plates together. It is direct proof of zero-point energy. If we could tap into this, we would have infinite power, but it also proves that the fabric of space is active. If the universe is expanding, is it creating more vacuum energy? If so, where does it come from? The conservation of energy is the holiest law in physics, yet the Big Bang model seems to violate it on the largest scales. We are getting something for nothing, and in physics, there is always a price to be paid. The price might be vacuum decay. If our vacuum is a false vacuum, a state of local stability but not the lowest possible energy, then we are living on a trapdoor. A quantum tunneling event could trigger a collapse to the true vacuum. A bubble of true physics would nucleate and expand at the speed of light. Inside the bubble, the laws of physics would change. Atoms would not hold together. Chemistry would fail. The bubble would incinerate the universe, converting it to the new state. We wouldn't see it coming because it travels as fast as light. One moment you are here, the next, the laws of nature that bind you together simply stop. This catastrophe could happen anywhere, anytime. It could have started a billion light years away a billion years ago, and the wall of death is rushing towards us right now. We would never know until it hit. The Big Bang might have set the universe on this precarious ledge. It raises the question, why is the Higgs field value just barely stable? It's as if the universe is balanced on a knife edge between existence and annihilation. That isn't the sign of a robust system. It's the sign of a fragile anomaly waiting to correct itself. Could vacuum decay be the great filter? Perhaps the reason the universe is silent is that advanced civilizations eventually trigger a vacuum collapse with high-energy experiments. Maybe building a particle accelerator the size of a solar system, something a Type 2 civilization might do, is what pops the bubble. The silence of the stars is the silence of a graveyard where everyone played with matches and burned the house down. We are the children playing with the same matches at CERN, unaware of the gasoline on the floor. The Fermi paradox is the shadow hanging over cosmology. If the universe is old enough for impossible galaxies to form, it is old enough for life to have colonized every star. The fact that they haven't implies a hostility we don't understand. Maybe the universe resets itself periodically, wiping the slate clean before any species gets too powerful. The cyclic universe model suggests regular apocalypses. We might be growing in the brief summer of a cosmic year, destined to die when the winter comes. The lack of aliens isn't a puzzle, it's a prognosis. Or perhaps the dark forest theory is true. The universe is full of life, but it is hiding. Hiding from what? Maybe hiding from the entities that inhabit the dark voids. Maybe hiding from the great attractor. If the cosmos is a dangerous, predatory place, then broadcasting our location, like we have been doing with radio waves for a century, is the stupidest thing a species can do. We are shouting in a jungle at night, wondering why no one is answering. not realizing that the silence is for our own protection. The Hubble tension is the smoking gun of our confusion. One method says the universe is expanding at 67 kilometers per second /MPC. The other says 73. This isn't a small gap, it's a chasm. It means we don't know how far away anything is or how old anything is. It affects every other calculation in astronomy. We are like sailors arguing over the length of a mile while navigating a storm. If we can't agree on the ruler, we can't measure the world. And the more data we get, the worse the disagreement gets. The universe is refusing to be measured. We use Cepheid variable stars as standard candles to measure distance. But what if they aren't standard? What if the physics of stars changes over billions of years? If our candles are flickering, our map is wrong. We assume the laws of physics are constant across time and space, but that is an assumption, not a fact. If the laws evolve, then looking back in time is like looking through a kaleidoscope. Everything is distorted, shifting, and unreliable. The red shift might be a lie told by changing light. To fix the Hubble tension, some propose early dark energy, a burst of extra energy in the early universe that disappeared. It's another epicycle, another fudge factor added to force the model to work. It's like adding invisible gears to a broken clock to make the hands point to the right time. It works mathematically, but it feels artificial. Why would dark energy turn on and off? It smells of desperation. We are adding complexity to hide the fact that the core theory is failing. Others propose chameleon fields, particles that change their mass depending on the environment. In empty space, they are light and push the universe apart. In dense areas like Earth, they become heavy and hide. It's a theory designed to explain why we never see them. A particle that hides when you look for it. That sounds less like physics and more like magic. But this is where we are, invoking shape-shifting particles to save the Big Bang. The desperation is palpable. The psychological impact of an infinite, eternal universe cannot be overstated. The Big Bang gave us a story with a beginning, middle, and end. It felt like a life. An eternal universe feels like a prison. It has no narrative. It just is. It strips humanity of the role of protagonist in the cosmic drama and reduces us to a temporary fluctuation in a static field. It is a colder, harder reality to accept. It means we are not going anywhere. We are just here, forever, in the churning machinery of eternity. Nietzsche called this eternal recurrence. If time is infinite and matter is finite, then eventually the atoms must arrange themselves in the exact same way again. This moment, you listening to this, me speaking, has happened infinite times before, and will happen infinite times again. The Big Bang isn't a start. It's just the turn of the wheel. We are trapped in a loop of infinite repetition. Every mistake you made, you will make again. Every pain you felt, you will feel again. This is the true horror of the infinite. In an infinite universe, everything that has a non-zero probability of happening must happen, and must happen infinitely often. There is a version of you that checked the closet. There is a version of you that didn't. There is a version of you that is king of Earth. In the vastness of the multiverse, or the infinite void, impossible is just a matter of distance. Somewhere, far away, the laws of physics might be different, and monsters might be real. Infinity is a concept that breaks the human mind, because it allows for every nightmare to be true somewhere. The idea that you have lived this life before is no longer spiritual. It is statistical. If the universe cycles, you are immortal in the worst way possible. You are a recording playing on repeat. The Big Bang is just the sound of the needle dropping on the record. The only hope is that the cycles are not identical, that there is evolution, change, a slow crawl towards something new. But the universe breakers suggest that the previous cycle was very similar to ours, leaving behind galaxies that look just like today's. The record might be skipping. Can we escape the cycle? Can we break the wheel? Some physicists dream of baby universes, using black holes to spawn a new reality, detached from this one. A lifeboat. If our universe is dying or trapped in a loop, the ultimate goal of intelligence might be to leave it, to punch a hole in the wall of reality and step into the bulk, to become the gods of a new Big Bang. It is the ultimate sci-fi dream, but it might be a survival necessity if the Big Rip or vacuum decay is coming. But we must also confront the limits of our cognition. Maybe we simply can't understand the universe. A dog cannot understand the internet. We are evolved apes with brains designed to find fruit and avoid leopards. Why do we assume we are equipped to understand 11-dimensional string theory or the origin of time? The anomalies might not be failures of the universe. They might be failures of the biological hardware in our skulls. We are hitting the ceiling of human intelligence. The universe isn't wrong. We are just too small to see the truth. As we move into the next phase of our investigation, we will look for the unified theory that could save us. The holy grail that unites gravity and quantum mechanics. String theory, loop quantum gravity, geometric unity. These are the contenders. But they are all struggling. The math is beautiful, but the evidence is missing. We are lost in a forest of equations looking for a path out. And the sun is setting. The universe breakers have cast a long shadow. And we need a light, fast. For decades, the theoretical lifeboat that physicists hoped would save us from the shipwreck of the Big Bang has been string theory. It promised a theory of everything, a beautiful mathematical framework where all the fundamental particles, quarks, electrons, photons, are just different vibrations of tiny, one-dimensional strings. It was supposed to unite the chaotic gravity of the macro-universe with the jittery quantum mechanics of the micro-universe, healing the rift that breaks the Big Bang model. But after 40 years of intense study, string theory has failed to produce a single, testable prediction that matches reality. We are looking for extra dimensions, 6 or 7 of them curled up at every point in space, but the Large Hadron Collider has found absolutely nothing. The silence from the particle accelerators is deafening. It suggests that our most promising map out of this mess might be nothing more than a beautiful, mathematical fantasy that has no relation to the physical universe we actually inhabit. We might be chasing ghosts in the machine of mathematics. A failure of string theory leads to the landscape problem, a crisis of infinite choices. The equations of string theory don't describe just one universe. They describe 10 to the power of 500 possible universes, each with its own laws of physics. That number is so large it makes the total number of atoms in our observable universe look like 0. Instead of explaining why our universe is the way it is, why light travels at this speed, why gravity is this strong, string theory shrugs and says, everything is possible somewhere. It transforms physics from a science of prediction into a science of geography in an infinite multiverse. It tells us that we are just a random coordinate in a chaotic landscape of possibilities. If this is true, there is no reason for the Big Bang or the constants of nature. There is only dumb luck. We are not special. We are just one of 10 to the power of 500 lottery tickets, and we happen to win the prize of existence. Compounding this crisis is the failure of supersymmetry, or SUSY. This was the theory that was supposed to stabilize the mass of the Higgs boson and explain dark matter. It predicted that every known particle has a heavy superpartner, a shadow family of particles waiting to be found. Physicists were so confident in SUSY that they practically treated it as fact before the experiments even ran. But the Large Hadron Collider has smashed protons together at near light speed for years, and it has found nothing, no superpartners, no shadow particles. Just the Standard Model, standing alone and naked in the cold light of the data. This great desert suggests that our fundamental understanding of particle physics is hitting a dead end. If SUSY is dead, then the mathematical foundation for string theory and dark matter cracks. We are losing the tools we built to fix the broken Big Bang model, leaving us with a mystery we have no way to solve. The hierarchy problem remains the most embarrassing question in physics. Why is gravity so pathetically weak compared to the other forces? A tiny magnet can lift a paperclip against the gravitational pull of the entire Earth. The Big Bang model offers no explanation for this disparity. It just accepts it as a set value. But some theories suggest that gravity is weak because it is leaking. If we live on a brain, a slice of 3D reality floating in a higher dimensional space, then perhaps gravity is the only force that can leave our brain and drift into the bulk. We might be losing the glue of our universe to other dimensions we cannot see. This leakage would explain why we perceive gravity as weak, but it implies that our universe is porous, bleeding energy into a dark, unseen void that surrounds us on all sides. We are trying to fill a bucket that has a hole in the bottom. This concept of the bulk is terrifying because it implies that our entire observable universe is just a thin membrane, a sheet of paper floating in a room filled with other sheets. We are trapped on our 3D island, unable to see or touch the monsters swimming in the deep water of the 4th, 5th, or 11th dimensions. But if gravity can cross between brains, then we might be able to feel them. The dark flow and dark energy could be the gravitational shadows of massive objects moving in the bulk, casting their influence onto our world like a hand pressing against a fabric sheet. We are being pushed and pulled by entities that exist in a direction we cannot even point to. It redefines the void of space not as empty, but as a barrier. A wall that separates us from the true, larger reality that dwarfs our pathetic little Big Bang bubble. If we abandon the singularity of the Big Bang, we might have to embrace the fuzzball theory of black holes. In standard physics, a black hole has a singularity, a point of infinite density where math breaks. But string theory suggests that black holes are actually fuzzballs, tangled balls of strings that have no event horizon and no singularity. They are physical objects, just incredibly dense. If this is true, then the universe didn't start as a singularity. It might have started as a fuzzball that unraveled. This removes the infinity problem, but replaces it with a structural nightmare. It means the fundamental building blocks of reality are not points, but tangled knots of energy. We are living in a universe that is essentially a giant ball of yarn that is slowly unraveling, and when the string runs out, the fabric of reality simply comes apart. Loop quantum gravity offers a different, jagged alternative. It suggests that space itself is not smooth and continuous, but made of discrete chunks or loops of gravitational field, woven together like chainmail. This means there is a smallest possible unit of space, a quantum of volume. You cannot divide space forever. Eventually, you hit the pixel. If this is true, the Big Bang wasn't a point of zero size. It was a big bounce. The universe contracted until it hit the maximum density allowed by these quantum loops, and then it rebounded. The repulsive force of quantum geometry saved us from the singularity. But a bouncing universe is an eternal universe. It implies we are caught in the lungs of a cosmic beast that breathes in and out forever. We are currently in the exhalation phase, but eventually, the inhalation will begin, and the sky will fall. The horror of the big bounce lies in the question of entropy. Every time the universe bounces, entropy, disorder, increases. If the universe has been bouncing forever, it should be infinite in entropy, pure chaos. But we see order. This implies that either there is a mechanism that wipes the slate clean, a cosmic reset button that deletes the past, or we are in one of the very first bounces. If we are in the first few cycles, then we are the ancients of eternity. But if the slate is wiped clean, it means that nothing we do matters. No information, no history, no legacy can survive the bounce. We are writing our history in water. It is a cycle of futility where civilization rises from the ash, only to be burned back into it, over and over again, with no memory of the previous pain. This leads to the mystery of the arrow of time. Why does time only move forward? The laws of physics are mostly time-symmetric. You can play the film backwards and the math still works. But in our experience, you can't unscramble an egg. The Big Bang provides the low-entropy starting point that gives time its direction. But if the Big Bang is wrong, if the universe is eternal or cyclic, then the arrow of time loses its anchor. In a mirror universe scenario, time might flow backwards in the other half. Or, in the heat-death future, time might cease to have meaning entirely. If nothing changes, time does not pass. We are moving towards a state of timelessness, a stasis where future and past are meaningless concepts. We are surfing a wave that is destined to crash into a stagnant pond. The black universe theory, or eternalism, suggests that the past, present, and future all exist simultaneously as a giant four-dimensional block of space-time. The dinosaur is still alive in the past. You are already dead in the future. Our consciousness just shines a flashlight on now as it moves through the block. If the Big Bang is just one edge of this block, then the entire history of the universe is already written. There is no free will. There is no changing the outcome. The anomalies we see are just fixed features of the block's geometry. We are characters in a movie that has already been filmed, stressing about choices that were made billions of years ago. It turns the universe into a static sculpture of events, frozen in eternity, with us trapped inside the marble. But some physicists, like Nimar Kanihamed, are going further. They are declaring that space-time is doomed. They argue that space and time are not fundamental. They are emergent properties, illusions that arise from a deeper, more geometric reality. They have discovered a structure called the amplituhedron, a geometric jewel that exists outside of space and time. By calculating the volume of this shape, they can get the answers to particle interactions without ever using the concepts of here or now. This is a radical departure. It means the universe isn't a place, it's the output of a geometric calculation. We are the user interface of a system that runs on pure math. Space and time are just the desktop icons we use to make sense of the code, but they are not the code itself. If space-time is emergent, then the Big Bang was not the beginning of the universe, but the phase transition where the illusion of space solidified. Think of it like water freezing into ice. Before the Big Bang, reality existed in a fluid, non-spatial state, a realm of pure quantum information without distance or duration. Then, the temperature dropped, and the ice of space-time formed, creating the rigid structure we live in. The cracks in the ice, the anomalies, the black holes, the quantum weirdness, are where the illusion is imperfect, giving us glimpses of the liquid reality underneath. We are walking on a frozen lake, terrified that the ice is thinning, unaware that the true nature of the universe is the water below, dark and deep and timeless. This brings us to the spookiest phenomenon in physics: quantum entanglement. Two particles can be linked across the universe, sharing information instantly, faster than light. Einstein hated it. He called it spooky action at a distance. But it is real. If space were fundamental, this shouldn't happen. The fact that it does happen proves that distance is an illusion. Under the hood, everything is connected. This leads to the ER equals EPR conjecture, which suggests that entangled particles are connected by microscopic wormholes, Einstein-Rosen bridges. The fabric of spacetime is literally stitched together by billions of tiny wormholes. We are not living in a void, we are living in a web of tunnels. If you cut the entanglement, space itself falls apart. The universe is held together not by gravity, but by the quantum threads of connection. The stability of our reality hangs by a thread known as the fine structure constant, or alpha. This number, approximately 1/137th, dictates how strongly light interacts with matter. It controls chemistry, the color of gold, the burning of stars, and the bonds of your DNA. The Standard Model says it is a constant, set in stone at the Big Bang. But observations from the Very Large Telescope suggest that alpha might be varying across the sky. In one direction, it is slightly stronger, in the other, slightly weaker. This alpha dipole aligns with the axis of evil. If alpha changes, then the laws of physics are not universal. There are regions of the universe where matter cannot hold together, where stars cannot burn, where life is impossible. We might be living in a rare, habitable zone of physics, a small oasis in a desert of hostile, broken laws. If the fundamental constants are changing, then the universality of physical law is a lie. We assume that when we look at a galaxy 10 billion light-years away, the atoms there behave like the atoms here. But if alpha is different, then those distant galaxies are alien in a way we can't comprehend. Magnesium might not bond with oxygen. Carbon might not form chains. The impossible galaxies JWST-Cs might be impossible only under our laws, but perfectly normal under their laws. We are judging the entire cosmos by the rulebook of our tiny parish. It suggests that the universe is a patchwork quilt of different realities, sewn together loosely, and we are naive enough to think the whole blanket is made of the same cloth. The KBC void is another blow to our ego. Studies suggest that our Milky Way is located inside a massive cosmic void, a region with significantly fewer galaxies than the average. Being in a bubble would explain why the universe looks like it's expanding faster than it should. The matter outside the bubble is pulling us outwards. If we are in a void, it resolves the Hubble tension without dark energy. But it means we are living in the boondocks of the universe, a lonely, underpopulated wasteland. We are not in a typical region. We are in a hole. This isolation distorts our view of everything. We are like a hermit, living in a desert, assuming the whole world is made of sand, unaware of the cities and forests beyond the horizon. But the anomalies get bigger, much bigger. We have found structures like the Hercules Corona Borealis Great Wall, a filament of galaxies that is 10 billion light-years long. This is more than 10% of the diameter of the observable universe. According to the Big Bang model, matter shouldn't have had time to organize into something this large. The cosmological principle states that on large scales, the universe is smooth and homogeneous. This wall is a giant middle finger to that principle. It is a structure so vast that it breaks the math we use to model the universe's expansion. It's like finding a mountain that is taller than the planet it sits on. It suggests that the universe has a backbone, a rigid structure formed by forces or events that predate the Big Bang itself. Alongside the Great Wall is the giant arc, a crescent of galaxies spanning 3.3 billion light-years. These megastructures prove that the universe is clumpy on scales that shouldn't be possible. If the universe is lumpy, then the Friedmann equations, the foundation of the Big Bang, are wrong because they assume a smooth fluid. We have been calculating the age and expansion of the universe using a simplified model that ignores the lumps. It's like calculating the volume of the Earth assuming it's a perfect sphere, ignoring the Himalayas and the Marianas Trench. The error isn't in the stars. The error is in our simplified assumption that the universe is simple. It is complex, jagged, and messy, and that messiness is hiding its true age. This clumpiness hints at a fractal universe. In a fractal, the pattern repeats at every scale. Atoms look like solar systems. Solar systems look like galaxies. Galaxies look like the cosmic web. If the universe is a fractal, it might be infinite in both directions, infinitely large and infinitely small. There is no bottom to the particles and no top to the structure. The Big Bang would just be a local event on one level of the fractal, a tiny explosion in a much larger self-similar infinite structure. This idea was discarded by mainstream science, but the Great Wall and the giant arc are bringing it back. It suggests a universe of infinite complexity, where we are just one layer of the onion, unable to see the layers above or below. Now, let us look forward to the dark. If the Big Bang is wrong and the expansion is accelerating without limit, we face the era of solitude. In a few trillion years, all other galaxies will have moved beyond our cosmic horizon. Their light will never reach us again. Future astronomers born on Earth will think the Milky Way is the entire universe. They will have no evidence of the Big Bang, no evidence of the expansion, no evidence of other galaxies. They will build a physics model based on a lie, that we are alone and static. It makes you wonder, what have we already lost? What evidence of the true universe disappeared over the horizon billions of years before we evolved eyes to see it? We might already be living in a truncated reality, analyzing the few crumbs left on the table. The ultimate fate in this model is proton decay. We assume atoms are eternal, but many grand unified theories predict that protons eventually fall apart. If this happens, matter itself is temporary. In the far, far future, numbers so big they are meaningless, every atom in the universe will dissolve into radiation. Stars, planets, you, me, we will all just evaporate. The universe will become a bath of photons and leptons, cooling down towards absolute zero forever. This is the heat death in its most absolute form. It renders all of existence, from the Big Bang to the end of time, as a brief, momentary fluctuation of matter in an eternity of nothingness. We are a glitch of solidity in a universe that wants to be gas. If protons do not decay, the future is even weirder. The universe enters the black hole era. Stars burn out, leaving only white dwarfs, neutron stars, and black holes. Over eons, gravitational interactions fling the dead stars out of galaxies, or they fall into the supermassive black holes. Eventually, the universe is just black holes in the dark, slowly evaporating via Hawking radiation. This era lasts for googles of years. Life, if it survives, must cling to the event horizons, harvesting the rotational energy of the black holes like huddled refugees around a dying fire. It is a grim mechanical survival in a universe that has turned off the lights. Civilization becomes a scavenger hunt for the last scraps of useful energy in the dark. Beyond the black hole era lies the iron star era. If protons are stable, quantum tunneling will eventually transmute all matter into iron-56, the most stable isotope. Cold, dead spheres of iron will float in the void for eternity. The Big Bang led to this, a scrapyard of rusty spheres drifting in the dark forever. It is a rusted tombstone for reality. The profound pointlessness of this outcome drives the cosmic horror of the modern scientific worldview. We are fighting to find a cyclic model or a multiverse, because the alternative is this absolute, cold, metallic permanence of death. We want the universe to be alive, but the math points to a graveyard. In this dark future, the Boltzmann brain becomes the dominant lifeform. In the eternity of the void, random quantum fluctuations will occasionally assemble a conscious mind. Over infinite time, these fluctuations will outnumber all the biological brains that ever lived. This means that in the grand timeline of the universe, you are most likely a Boltzmann brain that just materialized in the void with false memories of Earth, destined to dissolve back into chaos in the next second. The universe spends 0.00001% of its time with stars and life, and 99.99999% of its time in the dark. We are the anomaly. The darkness is the norm. We are the exception that proves the rule of the void. This timeline forces us to confront the event horizon of knowledge. Just as light cannot escape a black hole, there are truths about the universe that can never reach us. Due to the speed of light and the expansion of space, there are regions of the cosmos that are causally disconnected from us forever. We are trapped in a, quote, bubble of ignorance. We will never know what is happening in the galaxy next door if it is moving away faster than light. We are drawing maps with blank edges, writing histories with missing chapters. The theory of everything might be impossible, simply because we can't see everything. We are trying to solve a puzzle with half the pieces missing and the other half burning. The rare Earth hypothesis gains a darker edge in this light. If the universe is hostile, unstable, and prone to vacuum decay or massive radiation bursts from impossible early galaxies, then Earth might be the only lifeboat that made it. We look for aliens, assuming mediocrity, that we are average, but the silence suggests we are extremely lucky. The conditions for life might require such a precise balancing act of physical constants, a Goldilocks physics, that we are the only ones who won the lottery. We are drifting in a ghost ship, calling out to a sea that has killed everyone else. The loneliness is not an accident. It is a consequence of the violence of the cosmos. Even our own moon plays a role in this rarity. Without the moon's stabilizer, Earth's axis would wobble chaotically, causing climate shifts that would sterilize complex life. The collision that formed the moon was a random, violent accident. If that accident hadn't happened, we wouldn't be here to ask about the Big Bang. We are the product of a chain of catastrophes that somehow went right. This precariousness makes the meaning of the universe feel fragile. We are not the intended outcome. We are the survivors of a demolition derby. The Great Filter concept asks, what kills civilizations? Maybe it's not nuclear war or climate change. Maybe it's cosmic fatigue. As a civilization expands, it learns the true nature of the universe, the heat death, the vacuum decay, the futility of the cycles. Maybe the ultimate knowledge is despair. When you realize the universe is a trap with no exit, a machine designed to grind you down, you simply stop expanding. You retreat into simulations, into digital heavens, and let the physical body die. The silence of the aliens might be a sign that they found the truth, and the truth made them give up. Or perhaps we are the simulation's purpose. The ancestral simulation theory suggests that advanced future humans simulate their past to understand history. If so, the anomalies in the Big Bang are hints that the simulation started in media res. The programmers didn't bother to simulate the Big Bang perfectly because they were only interested in the 21st century. The impossible galaxies are just background textures. This makes us the stars of the show, but it also makes us puppets. We are dancing for an audience we can't see, in a set built of code, wondering why the painted backdrop of the sky looks a bit fake. We are approaching the final act of our investigation. We have dismantled the Big Bang, exposed the cracks in the laws of physics, and stared into the face of an infinite, uncaring eternity. The evidence is mounting that our reality is not a smooth, logical unfolding of events, but a chaotic, possibly artificial, and terrifyingly temporary state of being. The proof that the Big Bang is wrong is not just in the telescopes, it is in the logic of existence itself. We are about to ask the final, most dangerous question. If the Big Bang didn't put us here, then what did? And do we really want to know the answer? The cosmological principle asserts that the universe is homogeneous and isotropic. Basically, the same everywhere if you zoom out far enough. This is the bedrock assumption of the Big Bang equations. But the Hercules Corona Borealis Great Wall is a structure so massive it breaks this rule. It's 10 billion light-years across. To put that in perspective, the Big Bang happened only 13.8 billion years ago. Light barely had time to travel the length of this wall, let alone gravity having time to build it. Its existence is a direct violation of the standard model speed limits. It stands there like a monolith, a relic of a time or a force we refuse to acknowledge, proving that the universe is not a smooth soup, but a skeleton of giants. The existence of these megastructures forces us to consider primordial non-Gaussianity. In English, the initial conditions of the universe were not random noise. They were structured. Information was embedded in the universe from the very first moment. This implies input. Random explosions don't write code. They create chaos. But the Great Wall looks like code. It looks like a deliberate architecture. If the universe started with a blueprint, then the Big Bang wasn't an explosion. It was a construction project, and we are just the mold growing on the scaffolding. This architectural view aligns with the E8 lattice theory of the universe. Some physicists believe that reality is a projection of an 8-dimensional crystal lattice. The fundamental particles are just the vertices of this crystal. If space is a crystal, then it is rigid, ordered, and geometric at the bottom. The expansion we see is just us moving through the lattice, or the lattice growing. It turns physics into crystallography. We are trapped inside a diamond, mistaking the reflections on the facets for the movement of stars. The beauty of this theory is cold and hard. It removes the flow of time and replaces it with the rigidity of geometry. Let's reconsider the cosmic microwave background, CMB. We call it the afterglow of the Big Bang. But what if it isn't? Penrose suggests it's the Hawking radiation from the previous universe's black holes. But another theory, the ocean of light, suggests the CMB is just the light from distant stars in an infinite universe, scattered by dust until it becomes a uniform fog. If this is true, there is no edge to time. The fog just gets thicker the further you look. We are standing in a fog bank of light, assuming the fog is a wall. It is the Olber's paradox, resolved not by a young universe but by a dusty one. The universe goes on forever, but our vision is obscured by the smog of eternity. The lithium problem we mentioned earlier is actually a smoking gun for new physics. The missing lithium suggests that the nuclear reactions in the early universe were different than they are now. Maybe the fundamental constants were different. Maybe the weak force wasn't so weak. If the laws of physics evolve, then looking for a theory of everything is futile because the everything keeps changing. It's like trying to learn the rules of a game where the referee changes the rulebook every 10 minutes. Science relies on repeatability, but if the universe doesn't repeat itself, science hits a wall. We are chasing a moving target that is faster than our minds. The crisis in cosmology is not just about the age of the universe, it's about the nature of darkness. Dark matter and dark energy make up 95% of the universe. We are the 5% impurity. Imagine a sentient bacteria on a rock trying to explain the ocean, but it can't see water. That is us. We are building models based on the 5% we can see and ignoring the 95% ocean we are floating in. We call it dark because we are blind to it. It is likely that the dark sector is complex, filled with its own dark stars, dark planets, and maybe dark life. A shadow biosphere interpenetrating our own, completely invisible to us, but gravitationally touching us. We are walking through ghosts every day. The idea of shadow life is not science fiction, it's a valid solution to the dark matter problem. If dark matter has its own forces, dark electromagnetism, it could form atoms, molecules, and life. They would be invisible to us, and we to them. We could share the same planet, passing through each other like spirits. The only time we interact is through gravity. Maybe the ghosts we fear in folklore are just interactions with the dark sector. Maybe the great attractor is a dark matter megacity. The universe might be teeming with life, but we are separated by a frequency shift we cannot tune into. We are alone in a crowded room. As we stare at the impossible galaxies from JWST, we must ask, are they really galaxies? Or are they something else? Some theories suggest dark stars. Stars made of dark matter that are millions of times the mass of the sun. They would be huge, cool, and puffy, shining only in infrared. JWST sees infrared. What if the early galaxies are actually single, massive dark stars from the dawn of time? It would rewrite stellar evolution. We wouldn't be looking at a city of stars. We would be looking at single, monstrous giants that ruled the Dark Ages. The Titans that came before the Olympians. The axis of evil aligns with the Earth's motion around the sun. This is suspicious. It hints that the cosmic microwave background might be contaminated by our local environment, the solar system's dust, or the Milky Way's halo. If the CMB is polluted, then our baby picture of the universe is a fake. We are looking at the dirt on our own window and calling it the origin of the cosmos. It means we have no picture of the early universe. We are blind. All our precision cosmology, all our 13.8 billion years precision, is based on analyzing the dust on the lens. The psychological horror of the false vacuum cannot be overstated. It means the ground is not solid. At any moment, a high-energy event in the universe, a colliding black hole or a particle experiment, could punch through the floor. The bubble of death expands at light speed. We wouldn't see it. We would just vanish. The laws of physics inside the bubble would be different. Maybe chemistry is impossible. Maybe matter collapses. It is the ultimate game over. And the fact that our vacuum is metastable suggests that the universe is waiting for a push. It is a loaded gun pointed at itself. We survive by harvesting energy. But the second law of thermodynamics is a death sentence. Entropy always increases. Usable energy always decreases. The universe is a battery that is draining. Every star that burns is wasting energy that can never be recovered. We are spending our inheritance. There is no way to recharge the universe. This inevitable decline leads to the heat death. It is the slow suffocation of reality. No matter how advanced our technology becomes, we cannot beat entropy. We are fighting a war against the fundamental direction of time, and we are losing. But life is stubborn. Freeman Dyson proposed that in an open, cooling universe, a civilization could survive by slowing down its metabolism, thinking slower, hibernating for eons. As the universe cools, the moments of thought stretch out. Subjective time continues, while objective time stretches to infinity. We could live forever, but we would be frozen statues thinking one thought every billion years. It is a kind of immortality, but it is a lonely, frozen existence. The Dyson Eternal Intelligence is a ghost haunting the corpse of the universe. The end of cosmology is coming. As the expansion accelerates, galaxies will disappear. Future scientists will have no data to work with. We are living in the golden age of astronomy, the only time when the universe is observable. We have a responsibility to record the truth before it flies away. We are the archivists of reality. If we fail to figure this out now, the knowledge will be lost forever. The window is closing. The sky is turning off. We are the last generation that can see the stars as they truly are. The Copernican principle says we are not special, but the anthropic principle says we must be special, because if the universe were any different, we wouldn't be here to see it. This tautology is the battleground. Are we here because the universe was made for us? Or are we here because we survived the grinder? The evidence of the universe breakers, the violence, the vacuum decay, the radiation, suggests the grinder. We are not the chosen ones. We are the ones who haven't been crushed yet. The Omphalos hypothesis, the idea that the universe was created recently with the appearance of age, is usually dismissed as theology. But in a simulation, it is the most logical explanation. If you boot up a game, you don't simulate the billions of years of history, you generate a backstory and start the game. The impossible maturity of the early galaxies JWST found looks exactly like a backstory that wasn't fully rendered. The last Thursdayism idea, that the universe was created last Thursday with false memories, is indistinguishable from a perfect simulation. And the anomalies suggest the simulation isn't perfect. The Boltzmann brain nightmare is the ultimate solipsism. It suggests that you are the only thing that exists. The stars, the galaxies, the history, it's all a hallucination of a mind formed in the chaos. The Big Bang is just the backstory your brain invented to explain its existence. The more we find the Big Bang to be flawed, the more plausible the Boltzmann brain becomes. If the physical history doesn't add up, maybe the physical history isn't real. Maybe there is only the mind in the void. We are trapped between two horrors, the heat death, eternal nothingness, and the eternal recurrence, eternal repetition. Neither offers comfort. One is the end of meaning, the other is the prison of meaning. The Big Bang was supposed to be the third option, a story with a start and a potentially open future, but that story is dying. We are being forced to choose between the void and the loop. The investigation into the universe breakers is not just about galaxies, it's about finding a third door. The great attractor pulls us, the dipole repeller pushes us, the dark flow drags us. We are not static, we are being moved. Where are we going? To the center of the Laniakea supercluster? Or to something beyond? The final destination of our galaxy is a mystery. We are passengers on a train with blacked-out windows, feeling the acceleration but unable to see the station. The only thing we know is that the tracks were laid billions of years ago, and the engine is getting faster. The Fermi paradox screams at us. Where are they? The silence implies that the third door doesn't exist. Civilizations either die or they leave. Maybe they leave the universe entirely. Maybe they ascend to the bulk or sublime into the dark sector. If the universe is a sinking ship, due to vacuum decay or the Big Rip, then the smart rats have already jumped. We are the ones still arguing over the deck chairs. As we enter the final phase of this analysis, we must confront the possibility that science as a tool has limits. It relies on observation. But if the universe is a simulation, or a hologram, or a multiverse, the crucial mechanics are hidden backstage. We are trying to figure out how the play is written by watching the actors. We might never see the scriptwriter, but the flaws in the performance, the glitches, the impossible galaxies, are giving us clues. The curtain is tearing, and we are about to peek behind it.